Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get
Any
into
engine
it.
is a device in which one kind of energy is converted into another. In the case of internal combustion engines, thermal energy is converted into reciprocating motion of the cylinders, which, in turn, make the crankshaft rotate, driving the vehicle. Since all processes in the motor occur at a high frequency, frictional forces are generated, the destructive effect of which can be prevented by using a complex system but effective lubrication. To imagine how important is the proper care of this component of a modern car, you need to have at least a basic knowledge of the structure of the lubrication system, its purpose and principle of operation. This is what we are going to do now. Purpose of the CC of an automobile engine. The internal combustion engine is a complex set of components and assemblies that are linked together to ensure stable operation of the power unit. But since it has many parts that rub at high speed, their uninterrupted operation requires reliable lubricant delivery. This is what the lubrication system does. Without it, the engine would not last 10 minutes. Working of the power unit on dry is fraught with rapid heating of the rubbing surfaces to a critical level, after which, due to thermal expansion, there is a decrease in clearances with subsequent destruction of engine parts subject to increased friction. The complexity of the realization of the engine lubrication system is not only to ensure the delivery of lubricating fluid to the right place, although this is also a difficult engineering task, but also to ensure the circulation of machine oil in a closed cycle with minimal losses. Let us enumerate the list of tasks solved through the use of SS. Reduction of friction force due to formation of the thinnest protective film on the rubbing surfaces, cooling of surfaces of power unit parts, cleaning of technical fluid on the protected surfaces from metal chips and other solid contaminants, ensuring uninterrupted circulation of lubricating fluid at the required pressure, prevention of premature wear of SA parts. Lubrication system design. There are many different types of internal combustion engines that differ from each other on a conceptual level. Within each group, however, you are unlikely to find motors that are exactly the same. It is not surprising that the lubrication system can be realized in different ways, and therefore it is possible to describe its device only at a schematic level, and even then, referring to some hypothetical average statistical engine. However, this is quite enough for understanding automobile basics. Let's start with the crankcase, which is usually mentioned together with the sump. So, the sump is a part of the crankcase, located in the lowest part of the motor, and is an open container from above, into which the oil, which has fulfilled its main task, flows. Here it is cooled and settled, which is facilitated by special baffles, damping any oscillating processes arising during the movement of the vehicle. And further engine oil is directed to the oil filter. Note that the volume, capacity of the engine lubrication system of an average passenger car lies within the range of 3 to 6 liters. This is the place where the technical fluid is cleaned from the debris that inevitably appears on the rubbing surfaces as a result of intensive work and ingress from the outside. We have already mentioned microscopic metal shavings. Other contaminants can be soot and carbon deposits formed during combustion of fuel-air mixture, dust, and even dirt particles. The oil filter traps all of this, gradually clogging, resulting in poor filtration. Regular replacement of engine oil, according to car manufacturers' recommendations, allows to avoid such negative consequences of oil filter clogging as deterioration of lubricating properties of the liquid, which leads to accumulated loss of power of the power unit and more destructive phenomena for the engine. For to circulate through the system, it must be pressurized. This is the function of the oil pump, which pushes the fluid through the system, delivering it to the rubbing surfaces, towards the oil pan, to the oil filter and further around the circuit. There are two types of oil pumps used in modern vehicles: gear pumps and rotary pumps. Gear pumps are characterized by a constant level of pressure created in the system. Rotary units are able to change this indicator depending on the needs. It should be noted that depending on the design features of a particular engine, The pressure created by the oil pump in the oil line can be in the range of 2 to 16 atmospheres. The oil radiator is the next element of the lubrication system. Its main purpose is to cool the working fluid, since it does not reduce the temperature sufficiently in the crankcase sump. There are two types of radiators, airflow and liquid-cooled. The first ones are installed in such a place that a powerful flow of oncoming air runs onto the radiator. The second ones use coolant, circulating through the system. Ensuring the required pressure is not an easy task, as the engine usually runs irregularly, either with an increase or a sharp drop in RPM. When the vehicle accelerates, the pressure in the lubrication system can build up above a critical level, which can have irreversible consequences for the power unit. Relief and pressure-reducing valves installed in the area of the oil filter or oil pump are responsible for pressure relief in such cases. The signal for their activation is the data continuously received from the oil pressure sensor. If, for example, the oil filter becomes hopelessly clogged, the bypass valve opens an additional channel of fluid flow bypassing the filter to prevent the engine from stalling. The parameters in the system are monitored by sensors that monitor both the pressure and temperature of the fluid. The sensor controller sends the measured values to the onboard computer, and the ECU makes decisions, reacting to critical deviations accordingly. If, as a result, it was not possible to normalize the temperature or oil pressure, a light on the dashboard is activated, warning the driver of dangerous malfunctions. Read also, correct execution of the snake exercise on the driving range lubrication channels, ensure uninterrupted, high-pressure oil delivery to rubbing mechanisms. Flow into the system from the pump is carried out through the main line, one of the functions of which is to provide lubrication of the crankshaft bearings. It should be noted that this is the simplest scheme of a passenger car lubrication system. Real SS can contain a considerable number of additional components that improve its performance characteristics. The principle of CC operation. Most engines of recent generations are equipped with a combined lubrication system, the essence of which is lubrication of abundantly rubbing parts/nodes under a certain pressure and less intensively loaded by gravity/splashing. We have already considered the scheme of the engine lubrication system. Now let's go to the description of how it all works. When the ignition is turned on, the oil pump is started, designed to create pressure and pump fluid into the channels, which were empty during the parking of the car. It takes a few seconds, and that's how long the light for insufficient pressure in the lubrication system is on. Once the pump is running, oil from the sump starts to flow to the oil filter, then to lubricate the crankshaft bearings, connecting rod/root journals and camshaft, and then it's the turn of the upper connecting rod supports to the piston group pins. The next stage of the Big Silk Road is cylinder lubrication, where the fluid enters through nozzles or special holes located in the lower connecting rod support. All other components of the power unit are lubricated by spraying. The way it works is as follows. By flowing out through the gaps in the above-described lubricated surfaces, the oil is splashed onto the moving parts of the timing gear and crank mechanism. The splashing due to the high speed of rotation of the parts is so intense that an oil mist is formed, which envelopes all other parts of the motor. Subsequently, under the influence of Earth's gravity, the lubricant condenses and flows down into the crankcase pan, thus closing the cycle. The above scheme is the most popular and is called wet crankcase lubrication. At the same time, powerful engines use a dry crankcase system, in which a separate tank is used for intermediate storage of and the crankcase sump remains dry. Such a scheme allows to get rid of the dependence of pressure in the system on the level of liquid in the crankcase and the spatial position of the oil intake, which takes place in conventional lubrication systems. Classification of lubrication systems. There are several criteria according to which internal combustion engines are categorized. In particular, according to the method of lubricant supply to the power unit parts, under pressure provided by the operation of the oil pump, by splashing method, combined method. Oil supply to the rubbing parts under pressure is necessary if no other method is impossible to ensure accurately dosed delivery of lubricant to the part in a unit of time. An oil pump is present in most modern engines. It is not always rational to expend engine power to support the high pressure required to lubricate all the engine parts that need it. Therefore, where it is possible, the method of splashing is used, when the oil flows to the rotating parts and splashes all over the volume of the cavity, creating a dense oil mist, enveloping everything around it. It should be noted that the splashing method has many disadvantages. It does not provide uniform lubrication because oil condenses on the lubricated surfaces randomly. It requires a much larger quantity of lubricant because the lubrication process is quantized. The probability of oxidation of metal surfaces increases. In most cases, cars use a combined scheme of oil circulation in the system, which is characterized by the disadvantages and advantages of both of the above methods. The second important factor for SS is timely cooling of the oil heated up inside the power unit. If this is not done, the lubricating properties will decrease as the temperature rises, which threatens to overheat the engine. Existing methods of lubricant cooling: open crankcase ventilation method, crankcase cooling by closed ventilation method. In the first method, the gases formed in the crankcase are discharged into the atmosphere through a special hole. In the second case, the gas is directed back into the cylinder, where it is safely burned. Some models of power units are equipped with oil coolers, in which the cooling of engine oil occurs either by blowing a counter air flow or coolant circulating through the radiator tubes. Since the most widespread is the combined method of oil supply, it makes sense to talk in more detail about its varieties, already mentioned by us. Wet and dry crankcase. Wet crankcase. This method is commonly used because of its ease of implementation. Structurally, wet crankcase lubrication systems consist of the following components: oil pan, oil pump, oil intake device, pressure reducing valve, oil lines, fine/coarse filters, radiator, lubricant level and pressure sensors, oil filler neck. When the power unit is running, the oil pump injects pressurized fluid through the oil intake screen into the CSF, from where it is directed to the central oil line located in the cylinder block. From here, under pressure through the channels in the BC partitions, oil enters the crankshaft, lubricating first the main bearings, and then the connecting rod bearings. Excess grease is squeezed out through the technological gaps, and, falling on the rotating parts of the crankshaft, splashes throughout the volume of the engine, lubricating piston pins, internal surfaces of cylinders, other parts of the engine. In parallel, is fed through the oil line to the camshaft, lubricating its bearings, gears and axles of valve rocker arms. A small part of the lubricant, no more than 20% of the total volume circulating in the system, gets into the fine filter, from where, having been cleaned, it goes back to the oil pan. Read also how to pass the speed bumps on the car parallel to the engine parts. Part of the oil enters the radiator for forced cooling. A bundle of relief and pressure-reducing valves ensure the normal functioning of the system, with significant fluctuations in the pressure pumped by the oil pump. Dry crankcase. This type of SS is considered more efficient, but the technical realization of the dry sump method is more complicated, and the engine itself is more expensive. In such systems, the oil does not go into the oil pan, but into a special tank located independently, and from here the pump pumps it into the main line. The main advantage of such a system is to ensure stable oil supply to the powertrain components on uneven road sections, downhill/uphill gradients, side rolls. In wet systems under such conditions there is oxygen starvation, especially if the rough road section is long, and there may be a leakage of lubricating fluid through the crankshaft oil seals. Dry crankcase systems have no such disadvantages. Another advantage is that the engine height can be reduced, thereby increasing ground clearance or raising the center of mass. With this arrangement of the lubrication system, fluid consumption is reduced, and the original performance characteristics of the engine oil are less susceptible to change, i.e., the gets a longer service life before routine replacement. Typical composition of SS with dry crankcase: oil centrifuge, cooling radiator, full flow go filter, bypass valve, coil used for heating. Oil tank, pre-start oil pump, oil intake strainer, main oil pump. When the ignition is switched on, the pre-start oil pump starts working, pumping the from a separately located self-contained tank into the main line, bypassing all oil filters. This makes it possible to reduce friction at the cold start stage, which significantly increases the overall life of the motor. In winter, in severe frosts, oil becomes thicker, so before starting the engine, the liquid in the tank, main oil pump, and main line is heated by a special liquid-type preheater through a coil with preheated coolant. After the main oil pump has started, the from the tank is fed from the tank through two filters, a strainer and a full-flow FGO, into the main line. The process is the same as that of a wet lubrication system. After completion of the lubrication cycle, the liquid flows into the oil receivers of the power unit, from where 80 to 90% of it is directed to the autonomous tank by means of the pumping segment of the main oil pump. There is a radiator on the oil path where it is cooled. In winter, during the first minutes of engine operation, the oil has not yet had time to warm up to operating values, and in order to prevent the radiator from being destroyed, a bypass valve is activated. The remaining amount of oil, 10 to 20%, falls into the filter, which is an oil centrifuge, where it is cleaned and flows by gravity into the crankcase. In some modifications, there is no centrifuge, and fine oil purification is carried out by an additional incomplete flow filter installed in a single housing with a belt slit type filter. Peculiarities of CC operation and maintenance. Like any other node or aggregate of the car, the lubrication system needs timely and quality maintenance, as well as compliance with the recommendations concerning its operation. And the first thing that all drivers need to be sure to complete is the correct starting of a cold engine, especially in winter at sub-zero temperatures. During prolonged parking, oil under the influence of gravity flows down the line into the crankcase sump, and most of the engine parts remain without lubrication or with a minimal amount of it. By starting the engine, you provoke oil starvation, which, although short-term, manages to cause minor damage. Thus, non-compliance with the starting mode only aggravates the situation. In this case, the accumulating effect is much stronger, reducing the overall life of the power unit. Things are even worse when the motor is started at temperatures below 20 degrees of frost. The deficiency of lubrication will be felt until the oil is not warmed up to operating parameters, about 90 degrees. So in winter, special techniques should be used to reduce the load on the motor. Equally important is careful adherence to the maintenance schedule of the engine lubrication system. The timing of oil change together with the oil filter is usually specified in the owner's manual. For most foreign cars, it is from 10,000 to 20,000 kilometers of mileage. On a new car, the first change of technical fluids is made after 1,000 to 2,000 kilometers. For completeness of the picture, we will describe the main faults of the SS. There are not so many of them, but what is more important, there are only two symptoms at any problems: increase of consumption and decrease of pressure level in the system. Each of these signs can indicate a number of breakdowns, which an experienced motorist will not have difficulty diagnosing more accurately. If you notice that the oil is leaving faster than usual, it may indicate the following problems. The oil filter is not installed tightly. In this case, there will be leakage at the place of its attachment. The leakage is caused by a blown engine crankcase gasket or oil pump. There is through damage to the oil pan. Crankcase ventilation ducts are clogged. There are problems with the CVT and/or timing. A drop in pressure can indicate these troubles. The oil filter is severely clogged and needs immediate replacement. The pressure reducing valve is broken. The oil pump is not functioning as it should. Insufficient oil level. The oil pressure sensor is lying. Since the elimination of most of these malfunctions requires partial disassembly of the motor, such repairs are better to do with sufficient experience and knowledge. In conclusion, the lubrication system of an internal combustion engine plays a crucial role in ensuring optimal performance and longevity. By reducing friction, dissipating heat, and preventing wear, this system safeguards the engine's components under various operating conditions. Understanding the design and principles of operation not only highlights the importance of regular maintenance, but also emphasizes the advancements in technology that continue to enhance engine efficiency. As we move forward, Innovations in lubrication systems will undoubtedly contribute to more sustainable and powerful internal combustion engines. Thank you for watching, and we hope this exploration has deepened your understanding of this vital aspect of engine design.